through this, you're kind of thinking, oh yeah, I remember that. Maybe not. And if that's not the case, then here it is. So when we're having a rational exponent, meaning my exponent is a fraction. So if we have something like a to the 1 over n as my exponent, it can be rewritten as a radical. So if you have the nth root of a, where n is your index, and that is some real number, so it's not an imaginary number, there's no negatives underneath it, if it's even, then you can rewrite it as a rational exponent of a to the 1 over n equals the nth root of a. So you should be able to interchange back and forth between radical and rational exponent. Radical, rational exponent. Radical, rational exponent. So whatever your index is what goes in the denominator of your rational exponent. Right? You guys remember doing that? So if you had something like this, 64 to the 1/3 power, what would that be equivalent to as a radical? What would be my index? So the cube root of 64. Do we remember what the cube root of 64 is? 4, right? 4 times 4 times 4. Okay, or if you're really being lazy about it, you could just put in 64 to the 1/3 power in your calculator. Does everybody know how to put in a power other than 2 in your calculator? Use a little up arrow. Yeah, the little caret, right?
That's fine.
All right, what if we had 100 to the 1/2 power?
1 square root of 100.
It'd be the square root of 100, which is 10, right? So 100 to the 1/2 power is the same as the square root of 100, which would just be 10. Okay? So can we go back and forth? Do you guys remember doing this last year?
Yeah.
Vaguely? All right, so let's skip through that. So now what happens if you have something in your fraction in the numerator other than 1? So what if we just have m over n? So if we use the power rule of exponents, which you guys did exponents, I think, when I was gone, with Mrs. Leitz, power product says you can multiply these together, so you're kind of doing the reverse of the power product. So this can become a to the 1 over n all to the m power, right? And we know how to convert this to a radical. Then we just need to take it to the mth power. So what would that look like in action? So if we have 36 to the 3/2 power.
Do you do this too, like you just do 36 carats, 3 divided by 2?
Yeah, unless I say don't use a calculator, because you should be able to do these without a calculator. So is this going to be a square root or a cube root? It's going to be a square root. A square root of 36, and then I'm going to take that and take it to the 3rd power.
But what if I can't find square roots?
You can't take the square root of 36?
No. So it would just be 6. I'm not smart enough.
So it'd be 6 to the 3rd power. And then 6 times 6 is 36. 36 times another 6 is, what is that, 18, 19, 20, 22, 16? I'm going to require you to show me the transformation from exponent to radical. I'm not going to take your calculator away, but I am going to need to see all of this.
Okay.
So you can use your calculator to do 6 to the 3rd power, but I don't want you just typing in 36 to the 3/2. I mean, you could do that to check your answer, right? Okay. All right. Next one. What if we have a negative exponent? So if we had a to the negative m over n,
Take the reciprocal.
yep, then we just move it down to the denominator. So we put 1 over a to the positive m over n. So if we had 16 to the negative 3/4,
We would do 1 over 16 and we take the...
so 1 over 16 to the positive 3/4, is it going to be a 4th root or a 3rd root for my index? 4th root. So 1 over the 4th root of 16, and then I'm going to take that to the 3rd power. So the 4th root of 16 is 2. So I have 1 over 2, and now I got to cube 2, which is
2 times 2 is 4, times 2 is
8. So 1 over 8.
How come you only do it to the bottom? The denominator? Why do you only do it to the denominator?
Because that's where my whole thing moved to.
Okay, so you don't take like the square root of 1/16?
No.
Gotcha.
There's only the 16 that has the exponent of 3/4. All right. And we already did that, so don't even worry about that. So now let's just work through a whole bunch of the stuff. So now what's going to happen is you'll notice, if you don't write this whole directions, just put this problem. You'll notice in section 8.2 in the directions, it's going to add a new line that says, assume that all variables represent positive real numbers. And what that does for us is that eliminates the need for absolute value signs around our variables. You remember back in section 8.1, if it was an even index and a variable, then we had to put absolute values next to it. You guys remember doing that?
Yes.
Well, if you don't remember that, that's okay because you're not going to need to do it anymore. So in section 8.2, it gives us this statement in our directions, which eliminates the need to have to put in absolute values. So it's going to say, assume that all variables represent positive numbers. So now I don't need the absolute values to ensure positive numbers. Does that make sense?
If they're positive real numbers, then you don't need absolute value.
Right, because they're saying that it's positive. So 13 to the 1/2 should look like what?
13 with
The square root of
13.
13, is that a nice number?
No.
Can I simplify the square root of 13 any further?
No.
Nope, so we're done. All right, let's do another one. 6 to the 3/4.
The square, 4th square rooty thing.
So the 4th root of,
Yeah. 6.
so 6. Now what I can do is I can put that 3 on the outside, but the 4th root of 6, is that a nice number?
No.
No, so I'm going to put the 3 underneath with the 6. It's the same thing.
No, it's not.
Huh?
It would just be 6, right? No?
Well, you can't simplify a 4th root of 6,
6
right?
Times 6.
But now what happens is the following. What is 6 times 6 times 6? We just did that. 216, right? That's the same as the 4th root of 216. Now, do you guys remember simplifying radicals?
No.
Using your factor trees?
What's a
Now, I remember that being difficult for me.
So if I make two numbers, I multiply to get to 216. So 216 divided by 6 is 6 and 36. 36 is 6 and 6. This is 3 and 2, 3 and 2, 3 and 2.
So what's the answer?
Do you remember making factor trees like that?
Yeah.
Prime factorizations? Now back when it was square roots, you were looking for pairs. But this is a 4th root, so I'm looking for groups of 4. Do I have 4 of something? I have 1, 2, 3 3s, and I have 1, 2, 3 2s, so I do not have 4 of something, so I can't simplify that any further, which means that is my answer. The easiest way to do that is if you have your calculator.
Do you have to leave it in
radical
Fourth root of 216, or could you just do fourth root of 6 cubed?
take it to the 216.
Okay.
Okay. What you could do, what I do to check it to see if I can simplify it, is I would take 216 on my calculator and then I would divide it by 2 to the 4th power. So this is what I'm typing into my calculator. 216 divided by 2 up arrow 4, and I get 13.5. Since I got a decimal, then I know I can't divide it any further. If I do 216 divided by 3 to the 4th, I get a decimal. 216 divided by 4 to the 4th still gets me a decimal. So it's probably not able to simplify. Okay? All right, let's do another one. 9m to the 5/8.
I don't like this one, it's got a letter in it. That's sneaky.
So 9m to the 5/8. What's the exponent on the 9?
5/8.
1, right? So nothing's going to change there. That's just going to stay a 9.
Oh.
What's the index going to be on the m?
The 8,
8th root of m to the
5th.
5th.
How that looks.
Now think back to section 8.1 when we had something like this, the cube root of x to the 12th. What did that go to?
X
We would take 12 and divide it by 3 to make it x to the 4th. Can I divide 8? Can I take 8 m's out of 5 m's?
No.
No. So I can't simplify that any further, so I am done.
Okay. I still don't.
All right.
I don't like that there's letters in here now, because this seems like this is where we're going with it. And I don't like it.
So 6x to the 2/3 minus, now notice the whole 4 and x are being taken to the 3/5 power.
So we have 6 outside, and then the cube root of x to the 2nd
Cube root of x to the 2nd
minus
minus the 5th root of 4x to the 3rd. Okay. So I currently can't simplify this because 2 is smaller than 3. If this was larger than 3, then I probably could take some x's out. 4 to the 3rd power is what number? 4 times 4 is 16. 16 times 4 is 64. X to the 3rd. So now I have 6, 3, cube root of x squared minus the 5th root of 64 x to the 3rd.
I think we should be done. That should be the end of the problem. Can you find the 5th root of 64?
Well, so what we could do, I wonder if the book has you taking it to a common denominator. Let me look for a second before I steer you into a direction that I may not need to steer you into. Because I could take you an extra way. We don't want to do unnecessary work if we don't need to, right? Do they have you combining to make like terms? Where is that one?
Is this on our homework quiz?
No. This will not be on your homework quiz. Did all that. Yeah, no, they don't. They stop you there.
Oh wait, it's like 89. No, that counts for me. Well, without weekends, I counted last week and it was like 64. So
You're in close. All right, so we're going to stop there.
close enough.
So you stop there?
Stop in there. That's what the book has you doing. Stop in there.
Okay, alright.
Okay.
It's not a no solution, it's just there. All right. R to the negative 2/3. What's that one going to look like?
Cube root of
So it's going to be 1 over
Cube root of
cube root of r to what power?
the negative,
The 2nd. Good.
Oh no, it's just
because you gotta do the flippy thing.
And this is smaller than my index, which means I can't simplify it any further. If it was larger, then we would be able to take out some r's. Okay. A squared plus b squared all to the 1/2.
Does radical with a squared plus b squared.
Done.
Okay.
Wait.
Zach.
How come it wouldn't be A plus B?
Yeah.
Because if that was, so remember, a plus b written twice, like if I had that and took the square root of it, then that would eliminate one of them. What do you get when you multiply this? You don't just get a squared plus b squared. You get a squared plus 2ab plus b squared, right? So because of the plus, you can't just eliminate it. If it was the square root of a squared b squared without a plus sign, then it would be ab. Okay? Good question, because students do that, and they'll mess that up. All right, let me know if I'm going too fast. Square root of 10.
1. No, that's not true.
Hold on.
Can you simplify the square root of 10 any further?
No, you cannot.
No.
Why not?
Doesn't work.
Can you take...
It's a dirty number.
So if it's 10, it's a square root. Can any perfect squares divide into 10? Can 4? Can 9?
No.
Can 25, 16, 25? No. So that one's already simplified. Done. Can't do anything to it. How about the 4th root of 3 to the 8th power?
What is 3 to the 8th power?
Hey, you know what? Don't worry.
Well, but don't even do it, because look, it already has an exponent. What do you notice about 4 and 8?
Oh,
They're
reduce.
Whoa, can you like?
Can I divide 8 by 4 and get
2.
2?
Yep, turn me up.
Right? So this ends up being...
9.
Because if I think about turning it into your fractional exponents, right? What's going to be in my denominator of my exponent? 4. So convert it back to a rational exponent. 4 would be in my denominator. 8 would be in my numerator, right?
Can't believe it doesn't.
What is 8 divided by 4? 2. What is 3 squared? 9. Isn't that a lot easier, thinking it that way? Without needing a calculator?
We don't need this class to graduate. No, it's fun to.
Did you guys follow that? I know, this stuff's pretty dry. The 6th root of z to the 6th would be what?
3.
Z. Good. Do you need to write that one
No.
for our answer?
We're
All right.
moving and grooving.
2 to the 1/2 times 2 to the 1/4.
1 times 0.5.
What? So think back to this. Back in the day, when you had something like m squared times m to the 4th, what did you do with your exponents?
You added that.
Added them. So what am I going to do with my exponents with this problem?
3/4.
We're going to do 1/2 plus 1/4,
3/4.
which is the same as 2/4 times 1/4, or plus 1/4, which is the same as 2 to the 3/4, right? Okay. And then do we need to convert it? Do they want it converted? Nope, they leave it there. So 2 to the 3/4.
Your belonging sign is peeling. It's peeling.
That, I don't even know. That's from Mrs. Freeman's days of being in this classroom before my time.
I want to fix it.
So the most confusing part, I think, about this section is whether your answer should be in radical form or whether your answer should be in exponential form. Or
That always happens to me. I get to a quiz and I'm like, I know how to do the things, but I don't remember what names are.
The 3s are the
Then I look at it and I'm like, I don't remember. Then
what do
it's
you do with your fractions when, or what do you do with your exponents when you divide?
subtract.
We subtract. So this would be 5 to the 2/3 minus 7/3, which would be 5 to the negative 5/3. Making that positive would make it go to 1 over 5 to the 5/3. right?
Yeah.
Okay, and do they have us stopping there? Like, I feel like this is such terrible ways to write our answers. Yes, they stop you there. It's very hard for me not to put that into a radical and then rationalize the denominator and make it look appropriate. But the book has you stopping there. That's silly. If I had my way, I should write a textbook, math
You
textbook.
should. And then if you taught a college class, you could make all your students buy it and read it.
Yeah.
Math with
True.
PC.
That's what I'm gonna do. Then I'm gonna charge like a ton of money, and then my students will have to.
X to the 1/2, y to the 2/3, all to the 4th power, all over y. What do we do with our power to a power?
We
Multiply. So we get x squared, y to the 8/3, all over y. What am I going to do next?
now you're
Vanilla milk.
Going to do what with my y exponents? Subtract.
yeah
What's my exponent here?
0.
1. So 8/3 minus 1, or 8/3 minus 3/3 is
5/3.
5/3. So I have y squared, or x squared, and y to the 5/3.
All right.
Okay. X to the 4th, y to the -6, x squared, y to the 1/3.
These ones are really ones.
Well, we should flip the x up
Which would make me have how many up in the numerator?
That'd be X.
6,
Oh.
Yeah.
and then we should add 6 to the bottom, so we get 6 1/3.
So if I shift the x up, I get x to the 6, because that'd be 4 plus 2. If I move the y down, then I'm going to have y to the 6 plus y to the 1/3. So what's 6 plus 1/3?
6 times 3, and then add that to 1.
So 18/3 plus 1/3, which is
19
19/3,
thirds.
and that would be my denominator. So y to the 19/3. So you're just doing all your exponents, just with fractions in them. All right, is there anything else that's too crazy happening? We gotta do the ones that are inside yet. Let's do these. These are the fun ones. All right, almost there. 3 more.
Did you say these ones are fun?
Yeah.
Are you sure?
So, rule of thumb. If you are given a problem with like 2 sets of fractions, like these past problems, then put your answers with fractional exponents. If you're starting out with square roots or cube roots or 4th roots, then take it back to that actual, into a radical form. So these are starting out as radicals. But in order to be able to do anything with them, I need to convert them into fractions. So this would be x to what power? What would be the fraction for my exponent? What would be in the denominator?
To the 2/3.
To the 2/3, good. Times x to the 1/4. And then what do we do with our
Add them.
add them, right? So now I got to do 2/3 plus 1/4. In order to do that, I got to get a common denominator of 12. So that would be 8/12 plus 3/12, right? Times 4 times 4. So 11/12. We get x to the 11/12. Since it was starting out as a radical, I'm going to convert this back to a radical, which would be the 12th root of x to the 11th. Okay. All right. Second one. Same thing. Instead of multiplying, we're just dividing. So we have a square root of x to the 3rd over the cube root of x squared. So that's going to be x to what power? 1/3 all over x to the 2/3. 1/3 minus 2/3 is what?
1/3.
Well, negative 1/3, right? Which just means that it would be in my denominator. So it'd be 1 over x, oops, x to the 1/3. But I gotta take that to a radical. So 1 over the cube root of x. That's why I hate these problems, because they don't have you. Did I do that right? Oh no, I didn't do that right. What did I do wrong? Fix my mistake. I made a very terrible mistake.
Okay, well, let's rewind here.
6 times 8.
So they subtracted the 1/3 or 2.
My first step, my incorrectness is somewhere here.
Yep.
No, it's not 3 over 1. What is it?
3 over 2.
It is 3 over 2. Does everybody see how this is wrong?
Yes, 'cause it, yeah, classic.
3 over 2. So that means I'm doing x to the 3/2 minus 2/3. So there I got to make a common denominator of 9 over 6 minus 4 over 6, which is what?
5 over 6.
Yeah. So x to the 5 over 6, which would be a 6th root of x to the 5th.
Oh my god, I hope so.
Alright,
Okay.
you just gotta make sure you don't rush these.
Yeah, don't rush these.
Take your time.
Because you think they're...
Take your time, guys. Oh, okay.
Last one. A radical inside a radical. These are the best.
Don't do all.
So, start on the inside. What does the 4th root of z look like with a fraction exponent? Z to what power? Z to the 1/4?
No, why don't you doing that?
4 in the denominator, 1 in the numerator. So now if I'm taking the square root of that, what would the square root turn into as an exponent?
1/2.
Right. So now I'm taking z to the 1/4, and I'm taking that whole thing to the 1/2. So what do you do with your exponents there? So it'd be z to the 1/8, which is an 8th root of z. Right? All right.
You seen that with your kids?
Huh?
Old McDonald had a farm.
Oh yeah.
E-I-E.
That's it.
Just ask me if Guten Tag was Chinese.